Good afternoon, guys. First of all, thanks for the joining with us again. And today we are talking about JS variables and functions. Our main speakers are Sharad and Kavishka. Uh, yeah, I am inviting Sharad and Kavishka for their tech talk session.
Okay, thank you, Dalan. So, hey, yeah, nice to see you all after a long time. Be covering variables and functions today, and I'm really glad that you all are here for the third consecutive tech talk. So, yeah, let's jump into the topics actually. So, we thought of covering the basic variables and functions idea. I mean, we all are using variables and functions in our daily code. I mean, unless you are using some other language, for example, a brain fog. So there's actually a language like that which doesn't use variables at all. You guys can check on that. So we'll be also covering through hoisting. So for some people, for many of us, this is very familiar because we also went through this while ago. We'll be also going through variables, of course, and within that, we'll be covering about scopes, mutable, immutable variables, the difference between const and var, and of course the other main topic, functions, and there will be covering multiple types of functions. Okay, let's come to business then. So we all use variables and functions, right? So we all at one point in our school or something, we tend to take notes using a pen and a paper. So when the teacher teaches us, we are going to write it in a piece of paper, and then we study, and then we forget. That's how it is until the school life. So same thing happens with variables and like same concept, because we are storing a value and we are storing it temporarily. Similar to the above scenario I mentioned, we are going to anyway study and remember the things for a certain period of time in our brain, and after some time we are going to anyway forget about it, right? So same thing. So as the variable states in the name itself, the variables are changing, so they are going to be temporary, and we store a value for variable. So that's like the basic idea of it, and Sharad will go deeper in that. And for the functions, to get a brief idea of it, we all know how to set a meeting in Google Meet, right? Imagine like maybe 2-3 years ago, the Google initially had the feature only to set the meeting prior to the event. Maybe you can only set the meeting, like if there's a meeting today, you can only set the meeting today. Google didn't have that feature uh, to set the meeting like prior to the event, like now. See, now we can set the meeting like if the meeting is about to held in like 2 weeks, or if it's going to happen every day for the next week, we can set it now itself for the entire week, right? So we can schedule the meeting, right? But uh, so that's basically a function, because a function uh, so the function is basically it's a set of blocks um, which we use to do it's a set of code block. It's a code, and we use it to do a specific task, and they are reusable. And the reason we write functions is to prevent repetition. So even though we are creating a meeting, we are duplicating an event, or like we are scheduling the event, at the base, it's going to anyhow use the same function, and that's the specialty of a function. Okay, so now we have talked about what's a function, and now let's get back to hoisting. Doing a side promotion here, in case if you all are missing the technical discussion, join us, because we covered the session on technical discussion about hoisting. But let's learn something like let's see what happens actually internally when it comes to hoisting. So we know that, okay, moving the declarations like to the top of the scope, prior to the execution is basically hoisting, right? So when I mean by declaration, the declarations can be a function, it can be a variable, it can be a class, but that's not all. Hoisting is more than that, and it's about allocating the memory. It's about allocating the variables, the memory to run. So this happens prior to the execution. So as I mentioned, these are what I mean by declarations. To understand hoisting, let's go with the smaller example. Uh, JavaScript only hoists declarations. It doesn't hoist any initializations. To refresh your memory on these terms, uh, consider the orange block. Um, hold on. Yes, on the first line, it's declaring because we are not assigning anything. It's just declaring. So this is what we call as a declaration. In the second line, it's assigning the value group 3 for that variable. So we can call this as initialization or also assignment. And in the third line, it's calling the variable, in other words, using it. We also can call this as invocation because it's invoking the variable. Um, so we know we had an amazing session last time on the tech talk about JS engine, right? So we did cover about execution context. So we know that there are two parts. First one is like the memory allocation, and then we have the execution phase. So the entire hoisting happens during the memory allocation part, and that's where what we're going to focus. Um, let's consider another example. Okay, so same thing. Uh, the the output is printed by the comment here. So as you can see, initially when we call the tech talk, it is getting printed as undefined. But we are initializing the variable in the next line and assigning a value to it. And in the third line, when we try to call the same variable, it's printing group 3. But doesn't this contradict the previous point I just mentioned? I just mentioned that the JavaScript hoist only declaration. But here it's the initialization, right? Yeah, we are assigning something, but still, without throwing an error, the JavaScript console printed an undefined. Why was that? Um, that's what actually we need to understand what hoisting is all about. So, okay, let's go through this memory allocation part where the actual hoisting happens. So, hope you all can see the code block and the letters are visible. The first thing is first, um, functions, when they are getting stored in the memory, the entire function is referenced. Uh, if it's a variable, we are going to store the variable, whether it's uninitialized or undefined or with the value or something. But the function, the entire function block is referenced. That's something that we have to note about. And as you can see, when it reaches this point, it's getting referenced here. Um, the const let, when they are getting allocated to the memory, they are set to uninitialized. Always remember that constant let are like brothers and y is some like of another person. So here it is constant let is going to get uninitialized in the memory. So when it goes through this code, as it will see the const keyword and the let keyword, and then it will put into the memory as uninitialized. We are not going to worry about any assignment here. We are only going to talk about the declarations because that's how hoisting happens. So now for the final part, the undefined. The var is going to behave differently because they are not siblings as constant let. The var is going to get stored as undefined in the memory. So we learned three things. Function is going to get the entire function, and constant let is going to behave as uninitialized, and the var is going to get stored as undefined. Okay. During the execution phase, when we are calling the variable or the function. As we already, as the JavaScript like already referenced the entire function in the memory prior to the execution, we can call it from anywhere. And that's why even though you write your functions on the bottom of your script, but invoke it from where on the top, it still works. Reason is this: it has hoisted the function, so it is applicable. It's available like before execution. So that's why the function can be worked, and there are no errors, and the output can be seen here. But when we are using the var, as I said, the var is defined here. As you can see, the var city, we are assigning the value San Francisco, but during the memory allocation process, it is set to undefined. So that's why when we call the console log, it's going to print the undefined. So I think that's nothing complicated, right? Okay, but why does constant let behave differently? And that's why we have to understand the uh, term called temporal dead zone. So yeah, I know it's a lot, but it's not that hard. So as the name suggests, what temporal means is it's temporary, and what it means by dead is it's inaccessible, and what it means by zone is block. So the time where the variable is like the zone where the variable is not completely initialized is the zone we call as temporal dead zone. So if the variable is not initialized but declared, and we try to access it during that period, it's going to throw us a reference error. So now you have an idea of the reference error, but can we imagine it maybe? Um, Maybe we can see an example. Yeah. So let's consider this example. Remember that the JavaScript gives priority to the declarations, then the initializations and invocations. So with a thought about that, let's go through this code. So here we only use let here. So to understand temporal dead zone, we need to either use let or const. I think let is more easier. And here in the first line, it's declaring and initializing a value. In the second one, it's going to declare and assign the functions to that variable, and it's going to then later invoke it. But let's see how this exactly works um, actually. So hopefully y'all can see this screen. So it's the same function. By the way, Cliffs, note that in this visualizer does not show uninitialized. Instead of that, it is showing it as undefined. So let's visualize this. So the first line, it's going to call this one. So it's the next line to execute. So it's going to assign this value. So what actually happens is this shows both the assignment and the declaration together. But actually what happens is JavaScript first declares the value in the memory as uninitialized, as I showed in the previous picture. Now what happens is it's going to go through this one, and it's going to declare this or make this as uninitialized in the memory, and that's what actually happens. And then later only the assignment comes, where the value of group 3 is assigned to average team, and that's the third step which actually happens. And then for the fourth one, it's going to reference the entire function as it is, like shown here. So now the next one is, now we are going to call the make my best team function. So when this is called, um, it's going to okay. When this is called, it's going to go into this function, and it's going to check are there any declarations there or initializations. And there is, right? We have the let average team group not 3. So this is going to get hoisted within that function, and it is going to get stored as uninitialized. So now we try to access the average team, it's going to throw a reference error. The reason is the average team is still in the temporal dead zone, and we are trying to access the average team during the temporal dead zone, and that's why it's throwing the reference error. So hope you all have a clear idea about it, and let's go through this one more time. First, it's going to uh, get the declarations first and hoist it, and it's going to initialize as uninitialized, and then it's going to assign this value to average team, and then it's going to reference the entire function as the variable, and then we are going to invoke this, and when we are invoking it, the average team is going to get hoisted, and it is going to get stored as uninitialized inside the function, and then we try to call the console log as the average team is still in the temporal dead zone. It's going to throw reference error. The temporal dead zone is like we are coming out of the temporal dead zone only after the initialization. So imagine there's no console log, and you put the console log on the 9th line, there's an extra line, and at that point the group not 3 is initialized to average team, and that's where the temporal dead zone exits. I know it's a long process. Hope you're not thinking too much. Um, so as I mentioned, this is what happens when you try to call the city, sorry, the name. When you try to call the name here, it's going to throw a reference error because the constant let is still uninitialized. So once the memory goes through the, once the code goes through the entire initialization part, then the values inside the memory is replaced by the new ones. And at that point, the temporal dead zone is over. Yeah, so that's basically it from my end, and I'll be handing it over to uh, Sharad to take further on the mutable and immutable variables.
Hope you guys now have an awesome idea of how the hoisting works in JavaScript. Thanks to Kavishka on this one. So one of the things we come across a lot when going through Stack Overflow platform is that to suggesting to use a spread operator in order to copy an array instead of assigning to a new variable. This has to do with the data type being reference type in JavaScript. This is the concept of mutability and immutability. So sorry for the random thought. I just thought this might be quite interesting on this one. So without further ado, let's dive deep into this one. So primitive types versus reference types. The data assigned to a JavaScript variable can be of two types, primitive type and the reference type. There's a difference in how JavaScript treats these two data types. To know how they are treated differently, it's firstly understand how the difference is. What's the difference between the primitive types and the reference types one? Primitive types are simple atomic pieces of data in JavaScript. Primitive types are always saved and accessed by the variable's value and not as a reference to an object. So reference types are not atomic values. So it's the opposite of that one. But are objects that are made up of multiple uh, they are stored as reference in memory and not as independent values. So let's move on to the other slide over here. So there's a primitive types versus reference type table. There are 6 types of primitive types in JavaScript: undefined, null, boolean, number, string, and symbol. And also, there are 3 types of reference types in JavaScript: objects, arrays, and functions. So quickly move on to another slide. Okay, and see the database image here. How primitive types and reference types are stored in the memory is the basis of how they are different from each other. Let's look at a few of the examples to understand how this memory utilization is actually happening. So let's start with primitive types. As I mentioned before, primitive types are stored as single atomic values. assigned to variables in memory. Let's see this with an example. So here I have created a variable and assigned its value as charad. And now JavaScript would save this single atomic value in memory as such. Now, if we go to the next line, there's a new variable as name 2, and it is assigned to the value of the new variable. That so at this instance, JavaScript is going to go ahead and create a new space in the memory allocation. So the same value of the variable name, and it is the variable name 2. The new variable assigned to variable name 2 is entirely separate from variable name and does not have any reference to it whatsoever. So by the way, I will return back to this point again. So as to return with the console log with this one. So moving on to the reference types. Reference value on the hub on this hand are stored in the memory as reference objects, as opposed to the primitive types. Dedicated traces in memory, unlike the primitive types. Let's look at the following example over here. I have declared this like this in memory by JavaScript. So I have declared this person called object, so which will contain the name and the age of the person. And after name, I have given it like age 18. So let's just ignore the fact of 18 plus. Yeah, moving on. So here I have created another variable named person2 and assigned the same person object to person2. This is where things start uh, uh, getting a bit different on this one. So let's talk about the meaning of mutable first. Mutability could be said like something that could be changed or added to, whereas I'd say immutability. Immutability means that cannot be changed or added. So primitive values in JavaScript have anything added upon can be only reassigned, and hence I would say all primitive values in JavaScript are immutable. So let's come back to line number this one. Things like let's say let me copy this one and put it here, make it name, and run it and see. I would get charad as expected. Now let's assign the value comma to the variable name 2. So let's run this again and let's see if there's a difference. Yeah, as you can see, the variable name 2 was reassigned by JavaScript to comma. But this shows that the JavaScript treats these two variables separately, although the name 2 originally was copied from variable name 1. So this proves, in fact, that strings, in case of strings, so as this example, primitive values are immutable. So let's go to the reference types over here. I'm taking up too much time. Okay, I'm letting go. Let's pick up from the person object over here. Let's bring the value of both person and the person2 to the console and see what we get. Let me uncomment this one. So we don't need this. Let's comment it from this. Okay. Okay, now you can see it's outputted the same name and the age of those things. So let me try to change the person to like this. Let's see now what we're gonna get. So as you can see, this was created by referencing person object. So JavaScript creates a reference to the same object and remains because of this referencing of sorts the JavaScript, object types are going to be mutable. So a bit of good to know facts, since objects are mutable and it can be changed, the new properties can be added to the same object. That's what I said about in the first of this slide about slack overflowing for this operation. So if we take this zone and put curly braces on this one and three dots, become a spread operator. So if we run it like this, you would get the person to emphasize this because it's create a new object instance of the object. So this could be viewed as this. So let's move on to the other slides, I guess. Variables and constant. Let me take this up. Okay, variables and constants. Basically, this output on this one. Simply put, a variable can be thought of a name containers. You can place data into these containers and then refer data by simply naming the container. You know, so a bit of rules on this one. Variable name cannot be reserved keyword. So let, const, var, catch, post, stuff like that. You can't use those things as a variable name. Should be meaningful. So naming your variables like x1 or x0 something like that, f4 something like that, can't do that with a name. Can't contain a name or hyphen. Also consider these two instances, first name and the first name as a camel case and also with Pascal case. These two are going to be two different variables. So in JavaScript, variable declaration is loosely typed. Let's quickly move on to the scope one. So over here, I have declared the massive technical explanation of what a scope is going to be like. Let's just keep it as that. Let me explain it in a normal kind of way. Right, something else. Let's start with the question. Suppose that we are running into a issue when you define a variable in one place. And let's say suppose we are going to be using that thing in another place and it doesn't work. If it does. So as it does have two different values. You might be wondering why is this happening to me, or always why me, or something like that. So this has to do with an issue with understanding of scoping. So when talking about scoping, there are four types of scopes: global scope, module scope, function scope, and block scope. Need to worry about block scope and module scope. We are actually sorry. We actually have to worry about block scope and module scoping only, because most things that we are going to be working on is related to these two. So let me come back to that explanation on scoping. Scoping is essentially, it's just a set of code which has all your variables defined. In those variables, which are accessible only on the scoping. Anything outside that scope just will not have access to that variable. Okay, so let's look at the code declared over here. So I have a constant a which is equal to 1. There's also a function named as base scope, and also under that there is a constant declared as constant b, which is equal to 2, and there is also a console log which is under there. So after calling the base scope function, there is also, you can see there's also another console log over here, script over here. Let's actually run this bit and see what's we gonna get. Okay, we get this part as 1 and 2 for the first console log. For the second one, we hit a reference error. Reason for this one is b constant b is defined inside the base scope function as a variable constant b inside the function, and it is only available within this function only. By the way, I might be saying function a lot, so kindly do not take shots while I'm saying that, because sorry, bit of a joke on this one. Was thinking about some TV series on that one. So okay, moving on. The first level of scope I wanted to talk about is the global scoping one, because it's the easiest to understand since it's global. Actually, which means it is accessible within your entire declared project. So what have is here is a index.html file. I have two different scripts loaded here. One of it's not a module script, and another one is not just a normal JavaScript one. So this one is using modules. Another one is using the normal, just what we used to do. So actually, let me quickly run through what a module is. Like essentially, I would say module is a way to break up our code, like into various different files and import them into one another. So actually, what happens is JavaScript would actually break down the global scope and module scope into its own different scopes. So let's talk about these types. So on the non-module file over here, I have created a constant called global var, which is actually assigned to the value global here. And I have a comment over here. I will uncomment this and see this will come up as like that. Let me clear this one. Also, I don't need this one here. Yeah, this one. Take this will come up. Okay, we get global here out as the output. The reason for this one is that variable defined inside the non-module file. Sorry, got a message on that one. I was looking at that one. Is in a global scope. It is not wrapped in any functions, as you can see, or any if statements, and it's at the top of the file. Such is going to be a global variable which is accessible within your entire project. This is a thing that we have to avoid, because most of the time having global variables inside your code really messes up your code, because we tend to forget stuff on most of the things. So this is where the actually module scoping comes to into action. So let's take a look at this one. I have declared the export var over here with the constant named as this one, and one is exported over here. So like that. So let me come back to my script.js file. Let me actually, I don't need this one. I will comment this out now. Oh, actually remove that one. I could also. Right. Comment this one. Okay. We run this now. We could get the exported module over here as expected. So this is what the JavaScript module is going to do. Because what would happen if we import this one? Because I have declared it like export like that, or even a default one. So let me this one, out this one. Okay, we get a reference error on this one, because that's the difference between the moduling and stuff like that. Yeah. Okay. Let's quickly go on to the last section of this one. Okay. Function test on this one. Yeah, it's a function which is declared, which has the constant b with value 2, and under the if statement we have constant c as 3. So what would happen if we run this actually? So let's test. Okay, get a reference error. As it's saying, reference b is not defined, because this is only called up on the if statement. So let me try to actually move it to the top of these things because actually work on that one. See, this is what you called as block scoping. So actually, one trick to look at what's the scoping is like, we could actually track it with those curly braces. So that's what is about block scoping. So enough said with the scoping. Let's move on to the other section. Yep. Over here, I have declared some of more of the examples that we're gonna say about this. Yep. Over here, general definition of what a function is. Function is a block of code to perform a particular task or procedure or subroutine. To execute the function by calling whenever we want to do something. In order to make procedure work, we first need to define what a task of the function is supposed to do. Okay. So let's talk a bit about anonymous functions. So anonymous function is essentially a type of function which has no name, and we could say without the difference between the normal function and anonymous function is they are declared without an identifier. So let me actually load up some of the examples that I prepared. Okay. As you can see over here, I have declared two functions, one function declaration and another as a function expression. So a bit about function declaration and function expression. Well, it has to do with the function naming process, which as a result, we could actually remove the function name from the expression section as we are already assigning this constant variable as f. So we could actually remove this foo part. Actually, it would work fine. Run it and see. Yep, I suspected. We could remove those two part. I mean the naming one. So what's the use on this one? So only to remove the name on this one, that we that's what the anonymous function is about. Let's see further example. So we could so at this section there's a set timeout function. Uh, in this instance, we are passing one function to another. At this sort of integration, we could actually make use of anonymous functions because we don't actually need to as to initially invoke a function like this. We don't need to actually call stuff immediately. So for the to immediately revoke invoke a function also, you could use like this. Also when also to pass on arguments also, we could use implementations as this one. So in order to invoke immediately, we could pass on to this one as the parenthesis to this one. Yeah, under this paragraph. Yeah. Let's move on to the another slide quickly. Oh, you saw that one. Okay. The arrow functions. Hope you guys can know this guy because this was a huge meme on that in the day. Okay. So arrow functions does not have their own bindings to this arguments of super and should not be used as method. They can be declared without the function keyword. Arrow functions cannot be used as constructed. A bit of fact is that arrow functions are named as lambda functions in other languages. Okay, let me actually move on to the slides. Actually. Okay, so a bit of good to know facts about this one is actually arrow function is I would say the most important item introduced in ES6. So I'm going to be comparing the normal way of implementing functions with along with the functions implementation. So let me run up my environment on my end. Functions. Okay. In this JavaScript file, I have 4 examples of functions, which would help us understand the difference between the syntaxes of normal functions and arrow functions. Right now, these are normal functions, and we are going to check on them how they can be converted to arrow functions. So, so let's start with the name function over here with multiple parameters passed over here. So in order to convert this, we only need to, what we have to do is remove the function called and assign a variable to in variable name to invoke this one. So then after the parentheses, we could add the indicator of our arrow function. With also exception for these curly braces, we could remove this since it's a single output one. Moving on to the is positive section. So what we could do is similar to the last one. We could change this like this. Only difference is that we don't actually need to invoke it with the parentheses to denote the parameters like this. So the other one, let's look at the random number one. So under here we don't have any arguments to pass to this parameter. So in this case, we have to keep the parentheses as this one. So finally, I would say the thing that which is most useful for would be the arrow functions would be the most useful for the anonymous functions, because in order to declare the anonymous function, we actually don't have to do it like this, because if we could actually remove the function keyword and remove those extra curly braces, then this would look much better on this end. Yep. Okay. Then we
Into generator functions now. I mean, I was curious when knowing this for the first time. So in case y'all don't know about generator functions, before that, we'll get a brief idea about iterators. Because what is an iterator? So it's basically an object that can return a value. So it doesn't have to necessarily return a value. So it can return a value. And it also has another keyword, which is next. It's if you invoke that, it's going to return an object. So it's basically kind of an object returning an object with a value and a done, which is a boolean. So why iterators? Like, why do we need this? Like, have you ever had the have you ever got a chance to write a loop without breaking your PC? Like an infinite loop? No, right? But it's actually possible with iterators and generators. So I don't want to talk more about iterators. Let's go on further with generators. So take note of this emoji. And what's a generator? So generator is like a wrapper around iterators. So as it's a wrapper around the iterator, it can use the methods in the iterators such as next. And there's a special keyword here, which is called yield, which is only used inside the generator functions. To define a generator functions, we are supposed to add the asterisk in after the function keyword. So this is a basic example, and let's see what it actually does. Okay, so let me clear this. So here what I'm doing is I'm simply creating a generator function, a simple one, and then I'm calling it and I'm assigning it to a const, and with that const I'm calling the next. I mentioned that the generator functions, the iterators return an object, right? So as this is a wrapper around the iterator function, it is going to return an object. That object as a method called next, and you can invoke it. Yeah, I know it's different, but let's see the output. So as you can see, when I call the next, it's going to return me 1 and then 2. And if I try to add hey and I try to call it again, it's just going to return me values and it's going to say done false. What does it mean by done false? The reason why it's false is there is more to execute. So the function is not yet fully not fully executed, and there's more to execute, and that's why it's showing it as done false. So if you call it 2 more times, it's going to print 3, and there are nothing more to execute. So when you call it for the 4th time, it's going to print you undefined, because and it's going to change the done to true because it's actually completed. So if you actually think about it, then we can write a while loop and we can run it forever, and we can invoke it one by one and without breaking the PC, right? So that's what I'm doing here. So I initialized the ID, simply added a loop, and I'm calling this. So I'm returning the value and I'm adding it. So what happens is it's nothing different, similar to the previous example. It's going to give as much as I want. So, okay, that's not all. Um, there's something more to this yield word. This is not only a return statement, but you also can get uh, pass arguments to the yield. So you can use the yield as a return, and you also can yield as an argument. Wait, how can you use a you might be thinking, how can we use a return keyword as an argument? Okay, um, let's check this example. This is passing an array to the function, so this is not the one. Let's check this. Okay, so it's a simple generator functions, same while loop as example, similar to the example of the example 2. And here what I'm doing is something new here, which adding, I'm passing a parameter, passing an argument inside the next function. So when we call this, what's going to happen is the yield keyword, as you are passing the value inside the next, it's going to the next is consuming the value 3 and is going to send it to the yield, and the yield is going to assign it to input. So when we run, then technically it's going to be 1. And as you have, for the first time when we are running, it's going to input 1 because we are not passing anything. So it's just going to yield ID, which is 1. And then when we call it for the second time, what's going to happen is, oops, as you are passing the value 3, we are not passing null. So what's going to happen is, as there's an argument, it's going to take it and add it with this. So it's going to return 4. So if they add more like this, we can pass arguments likewise and call the generator like this. So, so why this is useful? Many use cases. I mean, as far as I R&D, they use these kind of generator functions to write libraries. And that's and the other thing about the generator function is, if you invoke it again, it's always going to give you a new instance. So here it's printing up to 16, but if I call it from the second object, it's going to give me 1 and 2. It's not going to get the value of the previous object. So that's a cool idea. So other than the next function, we also can use something called return. So imagine you have created your unending loop, but you want to exit out of it. So if you want to exit out of it, you can basically say, okay, I want to exit now. And if you call it after that, it's not going to return anything. It's going to be undefined because your return statement, you have exited out of the loop and it's going to done true. The return statement also can get an argument. So just let's say if we can exit at 100. So when we pass 100 into it, it's giving the value 100, but the done is also set to true. So this is just a basic overview of the generator functions, and you also can pass a generator function as an argument to a generator function, which we won't be covering today. And yeah, so that's it. I think we have reached our limit on the time. Um, And thank you guys, and thank you for the patience. And do you all have any questions?
You described, I think Shah described that there are six primitive types, right? So one of them is symbols. So we have seen these symbols everywhere, but we don't know what it is. Can you explain it, what it is, and what's the usage of?
Sort of a unique identifier that was created after some time. I guess.
And I have one thing to add. So as I remember, Shahad mentioned that we cannot use some reserved keywords as variable names, right? But I think if you try to declare a variable, a var variable with the name of let, it's actually legal. So that's kind of addition from my side. Just try to find out why it is the case. It's something to do with backward compatibility. And the last question from my side, actually, we talked about anonymous function, right? Functions without names. So, what is your recommendation? I mean, recommendation from you guys. What are the? I mean, we know use cases. Do you recommend using them?
Uh, for instance of calling one function within another thing or to immediately call like that, because then we could use anonymous functions, because no point in using another indicator to call the functions. Yeah, I would say on those kind of instances, anonymous functions would be a great thing.
You like have you tried to like mutate the generator function from outside?
No.
Like, is it possible?
Like you mean passing an argument in the function, or
No, like generator, the function, the meaning of generator function is it is a possible function, right? Like, but you can resume that function, but is it possible to like resume it from the outside, like without going inside the function?
so we did invoke the function outside of this. We just call the next keyword and to continue the execution of the function, right? You're not talking about it, right?
No, no, not that one. No, I don't know if it is possible. I just want to know if anyone has tried it.
Aman, I think you mean like in JavaScript, in Java, you can if it is a thread, you can interrupt the execution, right? Like that.
Yes, yes. Like I have used this Dart programming where there are streams, right? So your streams, you can mutate it, like you can add events to it. You can like close the stream and so on. So I tried to like do similar kind of thing with the generator function. I couldn't do it. Like I couldn't mutate it like outside the function. That's what I want to know. Like I know there is a stream API in the Node.js, but I wanted to see if it is possible with the generator functions. Like basically, when you add a new event, it should what do you call resume the function. Oh,
Mutation happens inside the iterators, right?
yeah, that's
And yeah, I actually don't have a valid answer for that, for your question.
Is it?
Question for Aman. Did did that issue come up from the JavaScript end or some other language that we used?
No. There is a feature in some other language like Dart or Java. I just wanted to like imitate that functionality with JavaScript with the generator function. When I heard about it, it felt kind of similar. Like I don't know if you have used the block library in Dart, like Flutter. So it has this generator function where you can yield new events and all. So it's kind of similar. But I wanted to like do the same thing with JavaScript. That was my experiment. Yeah.
It may be possible. No? We could take up this on the next week tech talk or something. We could extend on this subject. Yeah.
Yeah, basically what I wanted to do was like there is this union operators, right, in other languages where you can return a value from a function. It can be a let's say success or failure. So depending on that, we should change the UI. So in React, what we usually do is like we keep states, right, loading data and those kind of things. But we can forget to check for one thing, and it can lead to UI issues, right? But
Yeah.
the sealed union class is like this. What you can do is like you can't forget to use one of them. You have to cover all the scenarios. So this is available in Kotlin and Rust and all those languages. So what I want to do is like ultimately build a small hook or something to imitate that function, where we can change the states via events. So that's why I wanted to use the generator functions. I don't know if you are following. That was
That's it for this week, guys. So next week we will have the technical discussion. Hope to see you all there.